Regarding the homework for triangles, again, just like before, we have a whole bunch of vocabulary or drawing diagrams to go along with the vocabulary for the first few problems. You can use the notes in order to figure out the appropriate word that you should be using. Once we're through the vocabulary, we are tasked with constructing an equilateral triangle. So constructing an equilateral triangle, we have to use our compass. Basically what we do is we have 2 points in which we have to use our compass. Bullseye goes on one end, pencil will go to the other side, and we will draw a decent ways around it, and we'll flip it where the bullseye is now will go on the opposite side, and we just want to make sure our pencil is on the appropriate point. So I started with the bullseye on point A and drew a circle around point A. Now we do the bullseye on point B and we draw a circle around point B, looking for points of intersection. What I will do is place a nice little point at the point of intersection, and I will use my ruler to draw from point A to the point of intersection and from point B to the point of intersection. I now have equilateral triangle AB, and we'll label that C. So triangle ABC is equilateral. Classifying, remember, as a review, I'm not going to really go over these, but at an acute angle, all 3 angles are less than 90 degrees. Equiangular, all 3 are 60 degrees. Obtuse, we have one angle that is greater than 90 degrees. Or right angle, one angle is a right angle or 90 degrees. So based on that, we would go through and classify what kind we have: acute, equiangular, obtuse, or right triangle. We can also algebraically find the measure of each side. And for instance, this one, we have triangle FGH, equilateral triangle. FG is x plus 5, GH is 3x minus 9, FH is 2x minus 2. First, my suggestion is draw a picture. We know we have an equilateral triangle. Doesn't have to be perfect. It's triangle FGH. We know FG is x plus 5. G to H is 3x minus 9. And F to H is 2x minus 2. We are told it's equilateral, so all 3 sides are the same. Because all 3 sides are the same, I just have to pick 2 of them and set them equal to each other. So let's use x plus 5 equals 2x minus 2. The smaller of the x's gets moved because it makes life easier, so we'll subtract x. So we get 5 equals x minus 2. Add 2 to both sides. 7 equals x. So now that we know what x is equal to, I will take it and plug it in for x on any one of my 3 sides here. Again, ease is the name of the game, so x plus 5 is the easiest one. 7 plus 5 gives me 12. So all 3 sides are 12 units. And we can do that for any one of these problems. We can draw a picture for triangle LMN. This is an isosceles triangle, so that tells me 2 sides are the same. And these are the 2 sides. LM and LN are the same. So what you could do is set these equal to each other and solve for x. And we would go through, find each measure. So this one's kind of different because it's just markings. We are told one angle is 60, and we have B missing and we have angle A missing, with the markings of AC and AB being the same. The markings means these two sides are the same. Because we don't know what these angles are, we have to use a variable in place of it. And we know because these two sides are the same, the angles are going to be the same. So here, the angle across from the marking is 60, so that tells me angle ABC across from the marking is also going to be 60 degrees. It's known as the isosceles triangle theorem. Basically, it states if I have an isosceles triangle, the angles across from the sides are congruent. So because AC equals AB, that means the angles across from them. So that means angle BCA is going to equal angle ABC. If ACB gives me 60, that's going to give me angle ABC. EDF is a little bit different. Here we're told angle E is 40 degrees and we have these two sides the same. So because these two sides are the same, the angles across from them are going to be the same. Now we don't know what they are, but we can use a variable in place of it. So because they're the same, I can use the same variable. So let's use x. So if this angle is x, because the sides across from the angle are the same, the angles are going to be the same. Again, isosceles triangle theorem. I know in any given triangle, my angles are going to add up to 180 degrees. So 40 plus x is going to give me 180 degrees. So I get 40 plus 2x gives me 180. I'll subtract 40. So I get 2x gives me 140. Divide by 2. I get x equals 70. So angle EDF, which is just x, we found x is 70, therefore it's 70 degrees. And we can use that to our advantage, like in this one, find the value for each variable. Here we're told these two angles are the same, so that means the two sides are going to be the same. So we can put a little slash here. And I would take 3x minus 10 and set it equal to 2x plus 4. And number 8, again, it's a little bit different. 2x plus 3 for this angle across from that slash. This angle being across from this slash also tells me this is going to be 2x plus 3. I'll use the fact that all three angles add up to 180 degrees. So 2x plus 3 plus 2x plus 3. Little square means we have a 90-degree angle up there. So if I add these three angles, I'm going to get 180 degrees. I would solve for x. And then we would use the fact that we got to find x and the length of each side if it's an isosceles triangle with AB congruent to BC. So A to B is congruent to B to C, meaning they are the same, equal. So I would take that 4x minus 3, set it equal to 2x plus 5, solve for x. Here we have an equilateral triangle. All three sides are the same. Pick any two sides to set equal to each other, solve for x. This last one, find x and the length of each side if this triangle is an isosceles triangle with RS congruent to TS. So this tells me these two sides are the same. I would take 9x plus 2, set it equal to 6x plus 8, solve for x, plug it in to find the value, find the length of each side. So that is using properties of triangles and their sides, angles, and properties in order to figure out missing variables, missing angles, and overall length of sides.